Welcome to the Chapter 6 Geometry Review. First problem, determine whether each pair of figures is similar. I would focus on the angles. I have two angles that are 71 degrees. I have one that's 41 degrees. That means I need an angle in the second triangle that's 41 degrees. Since I do not have it, DEF and CBA are not corresponding, are similar because the corresponding angles are not congruent. Number 2, apply the dilations to the polygon with the given vertices, name the coordinates. So we're multiplying each by 4. So A prime is going to become 8, because 2 times 4 is 8, 4. Okay, so right away, it can't be C and it can't be D. And it is a dilation with a scale factor of 4 because that's what the notation says. So right away, I know that the answer is B. So in this problem, two ladders are leaning against a wall at the same angle as shown. The problem is they really don't indicate. They're leaning against the wall, and this angle here is the same angle as this angle here. They don't really show that in the drawing. It's hard to read these numbers, but that is 10 to 30. Two ladders are leaning against a wall at the same angle as shown. I think what they're saying here is this angle and this angle is congruent. So I have create two sets of corresponding triangles. So the distance from the ground to where the ladder touches the wall is going to correspond to the height distance where the longer ladder touches the wall, because these angles are the same. So 10 over 30 is going to be proportional to x over 54. So 30x equals 540. 540 divided by 30, you can probably do this one in your head, is 18. So number 3 is 18. Number 4, I know this one is confusing a lot of students, so you really want to draw a picture. Karen wants to measure the height of the street light outside of her house. So that's the street light. She places a mirror on the ground, and the mirror is 52 feet from the mirror to the edge of the street light. She's going to stand 14 feet from the mirror. So this length here is 14 feet. And I know this is confusing, but when it says her eyes are 5.8 feet above the ground, that just means that height is 5.8 feet. So the distance of the mirror to herself corresponds to the distance of the mirror to the street light. Her height is going to correspond to the height of the mirror. Okay, so 52 times 5.8 is 301.6 equals 14x, and 301.6 divided by 14 is 21.54. That's going to round to the streetlight being 21.5 feet tall. I'm going to clear some annotations here. Number 5, the postulate or theorem that can be used to prove that the two triangles are similar. There are actually 3 sets of congruent angles here. This is congruent to that. I wanted to change colors so you could see it better. This one is congruent to that one. And this one, having troubles with my colors here. So I have 3 sets of corresponding angles. are congruent. It's angle-angle similarity postulate. Remember, I only need 2. Problem number 6, solve each proportion. I'm going to simplify 14 over 20 to 7 over 10. Remember, it was 14 over 20. 14 divided by 2 is 7. 20 divided by 2 is 10. Now I'm going to cross multiply. X minus 7. And that's 10x plus 10. I'm going to subtract 7x from both sides. And I get 3x plus 10. I now subtract 10 from both sides. I get negative 17 equals 3x. So x is equal to negative 17 over 3. Determine whether each pair of triangles is similar. Which postulate or theorem did you use? So here we have 2 sets of corresponding angles that are similar side ratios because they are congruent. So they actually have a ratio of 1. And the included angles are congruent. Technically, this is side-angle-side congruence. But side-angle-side similarity also works because they want to know which pair of triangles is similar, to tell whether the pair of triangles is similar. So that's why it is side-angle-side similarity. Warning, problems 8, 9, and 10 come from being recorded during class, 5th period today. Problem 11 is not on the test, so I really want you to focus on 8, 9, and 10. I'm going to go through on these and talk about what you need to do to prove them. In all cases, we're going to be proving them with angles, with angle-angle similarity. Some people have said, well, Mrs. Falk, can't you solve for x? On these, you can't. Because the only way you can solve for x is if the triangles are similar. The directions don't tell you the triangles are similar, so you have to prove that the triangles are similar. So for instance, for number 8, from the drawing, what are they giving you?
That DC and AE are parallel.
Okay, so they're telling you that's marked that AC is parallel to DC. That's a given. Now, if I have I want red, 2 parallel lines, and they're cut by this transversal, angle A is congruent to angle C, correct?
Yep.
So I'm going to write here, angle A, whoa, I don't know why the dictionary popped up there, is congruent to angle C. And that reason is alternate interior angles. Now, I also could say 2 parallel lines cut by transversal ED. Why does this count? That angle E is congruent to angle D, correct? Angle E is congruent to angle D. And again, that's alternate interior angles. At this point, I have enough information to, oh my, there we go. Black, stay on the black, thank you. That triangle A, B, E is similar. Remember, A corresponds to C, B, D, by angle similarity. I only need to prove 2. There was another set of angles that I could have proven congruent. What were they?
Vertical angles congruence theorem.
Okay, I could have used the vertical angle congruence theorem. And what are my vertical angles here?
Angle ABE and angle CB.
Okay, angle A, B, E, congruent to angle C, B, D. Why did I have to use 3 letters here, but I only used 2 letters here? Yeah?
Because there's 2 angle, like they don't have, yeah.
Angle B actually has 4 different angles that have a vertex of B.
Well, there's 2 inside the triangle.
These 2 that are inside the triangle. It actually has the 2 outside the triangle also, correct?
Yeah.
So I need to be specific about which angles. At angle E or angle D, there's only one option. So to do this proof, I need to have this at the beginning. I need to have this at the end. Here is my work to prove 3 sets of congruent angles. I only need to have 2 of them. So if you put reason 2 and reason 4, statement and reason 2 and 4, it would be correct. If you put 3 and 4, it would be correct. There's multiple ways to do this. Do you understand now what I'm expecting you to be able to do in number 8?
Yes.
Okay?
So we were supposed to write it like that in the test?
Mm-hmm. And then,
Oh, that's how we prove it?
and then can you set up the math? Can you do 4 over 6? Oh, that's 5?
Yeah.
I'm sorry, I can't read that well. And now it's on the video that way. That's fine. Okay, corresponds to 16.
Minus 8.
Were you guys able to do that math?
Yeah.
Okay, you're able to cross multiply and solve for x. And then they wanted you to find AB, so you plug that back in. Right, if you don't do the proof part, you're going to miss questions for that. Yes?
So I did, because I'm confused on which numbers go on
Yeah.
Okay.
which ones. So I did 4x minus 8 over 5, and then I got x wrong.
Okay, because you probably did 4x minus 8 over 5. But then what did you put on the other side?
4 over 16.
Okay, because the
Yeah.
4 is corresponding with the 5. If you had done it this way.
16.
Now that's also why I want you to prove it first, because then you would be able to say, okay, AB corresponds to CB. If you write the similarity statement and you do that, then you know what's corresponding with what.
Okay.
At first I put 4 over 5 is equal to 4x minus 8 over 6.
Okay, that's going to also be wrong because 4 over 5, 16. So you're doing basically what's on triangle DBC over triangle ABE first. So here you have to do what's on triangle DBC over ABE. That make sense?
Yeah.
Okay. Do we have this one?
I got x equals 3.
How did you set it up?
5 over 4 equals 4x minus 8 over 16.
Okay, so hold on a second. You set it up as what? 5?
Over 4 equals 4x minus 8 over 16.
4 times 4x is 16x. 4 times negative 8 is negative 32. And what's 5 times 16?
80.
Is it?
It is.
I don't
Yeah, it does.
Okay, so 16x.
80.
What's 80 plus 32?
Oh.
I subtracted. Okay.
Okay,
Yeah.
I'm going on to problem 9. In problem 9, I'm first given 2 parallel lines. I'm going to try and go through this one a little bit faster. This actually is just like the one above it. I can prove I have 2 sets. I have a set of parallel lines cut by a transversal. So I can say angle E is congruent to angle D by alternate interior angles. I'm just abbreviating here. You can't do that on the test. I'm just doing it here so I don't bore you all when you're watching the video. I can also say angle C is congruent to angle A. by alternate interior angles. I can also say angle EBA is congruent to angle CBD by vertical angles congruence theorem, correct? Now I'm going to say triangle EBA, and I should have a little triangle symbol here, is similar. E corresponded to D, B to B, A to C. And that's by angle similarity. You only have to have, of steps 2, 3, and 4, you only have to have 2 of them. Okay? But I'm going through these, all the steps, because since it is from scratch, there's multiple ways to do it. Do we understand this one? You good? Okay, this will all be up on YouTube tonight. So, the last one. Okay? We're again given a set of parallel lines. In this case, though, these are my parallel lines, right? When they're cut by this transversal, do they make a pair of alternate interior angles that helps me? No, really what they create is this angle and this angle, right? And those are corresponding. So angle ABE. How come I have to use 3 letters for ABE and I can only use 1 letter for angle C? Right, B could be, there's 2 angles that have a vertex of B. But for C, there's only 1. Could I have used 3 letters for C? I could have said DCB, or DCA, or ACD, or BCD, right? Could I also have said angle AEB is congruent to angle D by corresponding angles, correct? Now, what's the third angle I could have said? Third pair of corresponding angles. Third pair of congruent angles.
Yeah. The both angles A on angle CAD.
I would actually just say A to A.
Yeah.
Angle A is congruent to angle A by what property?
Reflexive.
Okay? So, triangle ABE is similar to triangle ACD by what reason? Do we understand these?
So do you have to do all of them to prove it?
No, because it's 2 angles, you only have to do 2 of the 3. So all of these have been 5-step proofs. Step 1 has been the parallel lines that they gave us. Step 5 has been the angle similarity. 2, 3, and 4 have been 3 sets of congruent angles. You only need to do 2. So I don't care which ones you do.
So any combination?
Yes. Yes.
Wait, so Ms. Falk, we'll have to do one of these proofs for each one of the questions?
2. There'll be 2 questions like this, and you'll have to do 2 of these proofs.
Like 8 and 9?
Yeah.
Like 8 and 10?
Like 8, 9, or 10. Yes. Yes.
Oh, that's.
We also have to find the sides.
And you also have to, just like this, you also had to find x and then the measure the indicated parts. These are big questions, right?
I mean, she's
Yeah.
Are you telling us which ones we have to prove, or do we get to pick?
It's just like this. Did I tell you which ones to prove?
You said from all.
No, she said prove it.
I didn't know to prove.
Oh.
Yeah.
So tell me about the angles on the question.
You have to prove the triangles are congruent. Are similar. I'm going to stop the recording. Find x so that QS is parallel to PT. So PQ is 8 and QR is 5. RS is 15. ST is x plus 3. Some room there. That means we want to be able to set up a proportion where 8 to 5 is the same ratio as x plus 3 to 15. When this works, then that means that these two lines will be parallel, because the converse of the proportionality theorem tells us that if a segment intersects the sides of this triangle so that the ratios are proportional, then the lines are parallel. So, get my calculator here. 5 times x is 5x. 5 times 3 is 15. 8 times 15 is 120. I'm going to subtract 15 from both sides. 5x equals 105. So 105 divided by 5 is 21. So for number 12, the answer is 21. For number 13, determine whether QS is parallel to PT, and it also says to justify your answer. I think this one is multiple choice actually on your test. So PQ is 18, QR is 6. RS is 12, ST is 36. So that means that 18 over 6 should be the same ratio as 36 over 12. 18 divided by 6, that actually simplifies to 3. 36 divided by 12 simplifies to 3. And I would say that the answer would be the converse of the proportionality theorem. I think the answer key in class said something a little bit different, but as I told you, I just wanted you to be able to say yes. Really all I was looking for. Problem 14. If ABC, we're going to find that perimeter. If ABC is congruent to PQR, PQR has a perimeter of 36, AC is 12, and that corresponds to PR, which is 6. So ABC is what I have on the top. I want to find the perimeter of that, and the perimeter here is 36. So I could just realize that 12 is twice 6, so x is going to be 72. That's using number sense. I could actually multiply. And sometimes using number sense is faster, and we do that, and that's okay. But we want to make sure that we have that fallback, that we understand how to do it algebraically. So that's number 14. Number 15, I actually did a long way in periods 1 through 4, and then realized a shortcut in period 5. So I'm actually going to say how I would do this the long way, and then the shortcut I realized. So what I said was I want to find, basically I have two triangles. I have PST, and I have PQR. And these side lengths, that's supposed to say, PS and T. It's hard to read that. But the moral of the story is ST corresponds to QR. So 10 to 15. That is a ratio of 2/3. So that means if PS is 9, 9 to this long side here, it's going to be a 2/3 ratio. And when I do this, I get 2x equals 27, and x equals 13.5. So I have that this long side here is 13.5. Now I'm going to use this 2/3 ratio again. Actually, I wrote it on the wrong triangle here. This long side is 13.5. This 2/3 ratio again, 8 is the side length of PT. The corresponding side length is PR. That's what I want to find. And I actually said I was going to simplify this instead of 10/15 to 2/3. 8 times 3 is 24 equals 2x. X equals 12. So when I add all these up, 13.5, 12, and 15, I end up getting 40.5, which is the perimeter. Then I realized in 5th period, I did not have to do that much work. If the ratio of sides was 2 to 3, remember, the ratio of the perimeters is the same relationship as the ratio of the corresponding sides. So if I want the perimeter of the larger figure, it's much easier to say 10 plus 9 plus 8 is 27. So 2 times x is 2x. 27 times 3 is 81. And x equals 40.5. So sometimes you start doing something a long way and realize there is a shorter way to do it. Number 16. Find PS if ABC is similar to PQR and AD is altitude of ABC and PS is an altitude of PQR. And I'm told AD is 12, A to C is 16. I want to find this altitude. So 12, the altitude of the triangle to the left, corresponds to x, the altitude of the triangle to the right. And 16, triangle on the left, corresponds to 10, triangle on the right. I could simplify. I'm actually going to do that. 16 divided by 2 is 8. And 10 divided by 2 is 5. 8x equals 60. Is 7.5. For number 17, this is a bad question in that the directions aren't clear. They should say that triangle ABC is larger but similar to PQR. In order to do this, you actually have to set this up as a ratio of corresponding sides. So the altitudes of 3 over x correspond to, that says 9 minus x and 6. 3 times 6 is 18. 9 times x is 9x. X times negative x is x squared. I'm going to have a quadratic here. I'm going to add x squared to both sides so that I can get the x squared on this side. I'm going to subtract 9x from both sides. Add 18 equals 0. Want a quadratic. Want my x term to be positive. My a term to be positive. And now I can factor this. In order to do a quadratic, I need two numbers that multiply to get positive 18 and add or subtract to get negative 9. So the answers are negative 6 and negative 3. When I set those each equal to 0, I get x can be equal to 6 or x can be equal to 3. If x is equal to 3, then these two triangles are congruent. So as I said, I really need this to be rewritten to say that ABC is larger than PQR, or to say that ABC is similar to PQR but not congruent. So while there is not one like that on your test, it's still good for us from time to time to review quadratics. Are these two triangles similar? How do you know? Yes. And if you were asked to prove it, you could say angle H is congruent to angle K, because that's given. They're both 39 degrees. Then, hopefully you would see you have two sets here of vertical angles, but this angle and this angle are vertical angles that are going to be congruent, and they're parts of the triangle. So I'm going to say angle HMG is congruent to KMJ. You could say JMK as long as M is your vertex. But since I already know that H and K are congruent, I'm going to try and set them up in an order that will also work when I write a similarity statement. And I know they're congruent by the vertical angles congruence theorem. Now I can write that triangle HMG is similar to triangle KMJ, and that's by angle similarity postulate. Number 19, what theorem or postulate proves the two triangles are similar? So in this case, you cannot assume that these are going to be the same ratio. You know that this angle is congruent to itself, and I'm actually going to label these like A, B, C, D, E. So I know that angle A is going to be congruent to angle A by reflexive property of congruence. And actually, before I even do that, I should put up here my given, because it's hard to see, but those are parallel lines there. So I labeled this line segment BC. I labeled this other one segment DE. And they're parallel to each other, and that's given. So now I can say that angle ABC is congruent to angle D by corresponding angles. I could also have said angle ACB is congruent to angle E by corresponding angles, but I only needed to say one of them. So now I can say triangle ABC is similar to triangle ADE, and once again, that's by angle similarity. Okay? Once again, for number 20, I know the kids are saying in class, well, couldn't it be side, angle, side? No, you do not know that this and this are congruent. And it's not side, angle, side. This would be angle, side, side, and we have discussed that doesn't work. But here you are told that if I label these, let me just label that. I'm going to label it A and a C. Angle A is congruent to angle C because I'm given that. I'm going to label this B. I'll label that D. I'll label that E. So I can write A, B, E. It should be angle ABE is congruent to angle DBC, and that's vertical angles congruence theorem. Now technically, if I wanted to write this like I'm going to have to write a similarity statement, I know that A corresponds to C, so that means that E is going to have to correspond to D. So I'm going to rewrite it that way. It just makes it a little bit easier for me to then write the triangle similarity statement of ABE is similar to triangle CBD by angle similarity postulate. For number 21. They want the new points. You just have to list these. Everything is being multiplied by 3. So your J prime, 1 times 3 is 3. 4 times 3 is 12. K prime. 6 times 3 is 18. 4 times 3 is 12. L prime. 6 times 3 is 18. 1 times 3 is 3. And M prime. 1 times 1 is 3. 1 times 1 is 3. Number 22. So for number 22, it does not give you a similarity statement. You have to figure out if there is a way to make these similar. So what I would say is list them smallest to largest. JK is 10. That's actually not the smallest though. LJ of 8 is the smallest. Then JK is 10. KL is 13. Compare that with the shortest side here, which is ST is 24. Then TR is 30. And RS is 39. 8 times 3 is 24. 10 times 3 is 30. 13 times 3 is 39. So they are similar. They want a similarity statement. I'm going to write L, J, K. So I'm just going to put these in the order I have them here. And that's triangle. That's an L, J, K. Is similar to triangle S, T, R. For number 23, I'm going to do the same thing here. Okay, so the short, okay, in triangle PQR, actually I'm going to do it like this. P to Q is 5. Q to R is 18. And angle Q is 36 degrees. Okay, then in BCA, okay, CA is 10. That's the shortest side to 37. Okay? And this is 36. No, these are not similar. Because 5 to 10 is not congruent to 18 over 37. Number 24. State the postular theorem that can be used to prove that the two triangles are similar. So in this case, you have that angle A is congruent. So 21, actually I'm going to do this other side first. 18 is the shorter side. 21 is the shorter side. And then 24 and 28. 24 and 28 are both divisible by 4. You get 6 over 7. 18 and 21 are both divisible by 3. You get 6 over 7. So they are congruent. Sorry, they are similar. It's by side angle side similarity because you have one set of congruent angles and two sets of corresponding side ratios that are proportional. State the postular theorem that can be used to prove the two triangles are similar. You have two sets of corresponding angles are congruent, so it's angle, angle, similarity. I hope this has helped you, and now you feel ready for the Chapter 6 test.